Yes, it is a beautiful morning. You know why? Because today we're going to learn the SAM method for factoring. And that is when there are three terms and the coefficient of the x squared is a 1. So, before we do that, though, we're going to talk. Yesterday I talked about how factoring is a hierarchy. There's step-by-step process. And to do this, we're going to create a flow chart to help us through. So we're going to do it step by step. And you need a clean piece of paper for this. And leave a little space at the top because we're going to put another bubble at the top eventually. But, about a quarter of the way through, you're going to write look to factor out a GCF. Okay, for right now, that is where we're always going to start out at. And so far, once we look to factor out a GCF, then we had difference of squares. And difference of squares was when there was two terms. So you're going to draw an arrow and write two terms. So after you look to pull out a GCF, whether you factored it out or not, if there's two terms, you're going to go this direction, follow this path, and the options are then difference of squares. And remember, difference of squares is when you have two terms. Both of those terms are perfect squares, and they're being subtracted. So if you notice again, two terms, both perfect squares being subtracted, and that factors to a plus b times the quantity of a minus b. Put that in a circle. And your other option is maybe they're not perfect squares or they're not being subtracted. Then you can't factor further. So I'll just write not perfect squares or not being subtracted. Okay. And today what we're going to look at is what happens if we have three terms. So we can go ahead right away, make a little bubble that says three terms. And what's going to happen when we have three terms. Okay? And we'll come back to this flow chart later. But write this down, keep this in a safe spot. This will organize your thoughts as factoring gets complicated. All right, back to our SAM, the reason for the beautiful morning. What we're looking at today now is three terms, three things separated by addition, subtraction, one term, two terms, three terms, and that coefficient being a 1. And you have some steps here. So your first step is to make two sets of parentheses that are being multiplied together. So this is now really reverse of FOIL. Before GCF was reverse of distributive property, difference of squares was reverse FOIL. This SAM is also reverse FOIL. And you're then going to say, so if we look at our example here, x squared plus 6x plus 8, there's no GCF. There are three terms. And first step, and there's a 1 in front. That's how I know I'm going to use this SAM. So I make two sets of parentheses. What times itself is equal to x squared is your second step. Well, that is always going to be x times x, and you put the x's in the first terms of each one. Then this is where the SAM comes from. It says what multiplies to the last term and adds to the middle term. So notice, above the last term we have an m, and above the little term we have an a, which means m is multiply, a is add. So now again, we're saying what multiplies to 8 and adds to 6. Well, there's only a few things that multiply to 8, 1 and 8 or 2 and 4. And the only option that would add to 6 is 2 and 4. So I'm going to put it both 2 and a 4 here. And then the only way that it works so that they multiply to be positive and add to be positive would be if they're both positive. So that is now factored. And you can always check our answer with FOIL. X times x is x squared. X times 4 is 4x. 2 times x is 2x, so that'd be 6x when I add them together, and 2 times 4 is 8. And so again, we have this shortcut of SAM now as a way to, or an acronym to remember what each term represents. So S stands for single x squared, so kind of two S's in there. Single, meaning there's a 1 in front, and squared, single in front of the squared. The A stands for add, so it has to add to 6, and M stands for multiply. Multiply to that last term. In this case, it was 8. Okay, SAM is just an acronym, but it's a good acronym. All right, so if we look at example 1, it says factor the quadratic expression x squared plus 5x plus 6. Again, if we follow our flow chart here, we are still looking for a GCF first. That's where we always start. There is no GCF though. So then we follow our steps up here. Make 2 sets of parentheses. Done. What times itself is equal to x squared? That's step 2. X times x in the beginning of each parentheses. And then we do with that m and the a. So what multiplies to the last term? So again, if I write SAM, multiplies the last term, which is 6, positive 6, and adds to positive 5. Well, your factors that multiply to 6 are 1 and 6 or 2 and 3. And although I can get 5 from 1 and 6 and 2 and 3, I have to be careful of my signs here, because the only way I can get positive 5 added and positive 6 multiplied is if I use the 2 and the 3, and they're both positive. If we look at example 2, I have x squared minus 5x minus 6. It says identify the factor pairs of C. So we're going to, again, do this. There's no GCF. And so I can go ahead right away, make my 2 sets of parentheses, write my S, my A, and my M. I have x and x. And we're trying to figure out what multiplies to the last term, negative 6, and adds to the middle term. So again, the things that multiply to 6 are 1 and 6 and 2 and 3, but now I have to get them to multiply to negative, which means one of my numbers have to be negative, and add to be negative as well. So the only way I can get them to add to negative 5 is if the 2 and 3 is if they were both negative, but if they're both negative, when I multiply them, they become positive. So that can't work. So I have to use the 1 and the 6. And whenever I multiply to get a negative, I know one has to be negative and one has to be positive. And it has to add to be negative, so my larger number has to be negative. So again, negative 6 times 1 is negative 6, and negative 6 plus 1 is negative 5, which is what I wanted. And so therefore, this one is finished. I can check this if you really want. And again, the check would be to FOIL, x squared minus 6x plus x minus 6. And I would get x squared minus 5x minus 6. And it does check. All right. Now, this is where it can get a little tricky. It says, note, when factoring, always factor out a GCF first. Once you have factored out the GCF, continue factoring by following those steps. So again, this is where that flow chart is going to come into play. Notice at the very top, you always start at the top here. If you want, you can write the word start up here. We're looking to factor out a GCF. Okay, always start there. So for this example here, we do have a GCF. And if your leading coefficient is ever negative, like notice the number in front of my largest exponent is negative, you always want to pull that negative out as well. So my GCF is 2, okay, but it's also, since my leading coefficient is negative, my GCF is also going to be a negative number, so it's going to be negative 2, and they also all have an x in it, so my GCF is negative 2x. And remember, whenever you do GCFs, the GCF goes in front, so I have a negative 2x in front. GCF is the reverse of the distributive property, so you only have one set of parentheses, and then you divide everything by negative 2x. So I had 3 terms to start. After pulling out a GCF, I should still have 3 terms. So the negative 2 divided by negative 2 is 1, so that's fine. X cubed divided by x is x squared. Negative 8 divided by negative 2 is positive 4. X squared divided by x is x. And negative 8x divided by negative 2x is positive 4. From there, we're still following that flow chart. I pulled out a GCF. Well, now how many terms do I have inside those parentheses? Well, I have 3. 1, 2, 3. All right. And this is where the next thing comes into play. So if you get your flow chart out, we're going to say the coefficient of x squared being equal to 1. Coefficient means the number in front of x squared. So all these ones that we were doing so far, the coefficient, the number in front, is a 1. Now, the number directly in front of this x squared is a 1, so I know I can do this. So if the coefficient of x squared is equal to 1, we can write SAM factor. Okay, you still have to remember how to do those factoring, but at least it tells you, get your mind going on what kind of factoring to use. So I now know that I'm going to have to SAM factor this. So write my S, my A, my M. Remember, S stands for the single x squared. So I go x and x. M stands for multiplies to 4. A stands for adds to 4. So the only things that multiply to 4 are 1 and 4, 2 and 2. And the only way I can get them to add to 4 is if I use 2 and 2. And they both have to be positive. And I'm now completely factored. But again, the key thing is you always want to make sure you look for a GCF first and then keep factoring from there. All right, hope you enjoyed this.